Good morning. Today we're on lesson 113 and we're going to discuss direct and indirect variation. So if I tell you that A varies directly as B, here's how you set it up. All right? This K is called the constant of proportionality. So it's going to be different for every problem. All right? The key is to remember when it's direct variation, it's in a straight line, just like this. Okay? The other one we'll have today is inverse variation, or varies inversely. This will be set up as A equals K divided by B. So this is direct. And this is inverse. Okay, if you'll remember that, we'll be fine. The first thing we're going to do in each one of these problems is to solve for K. They're going to give us a set of data. We'll find out what the constant of proportionality is, and then they'll ask us to find a missing piece. So we'll have to use that constant that we found. So if you'll turn to page 475, the first one says this. The mass of a substance varies directly as the volume of the substance. So the first thing I would do is write M equals KV, mass, volume. Always use letters that will help you know where to plug the numbers in. If the mass of 2 liters of the substance is 10 kilograms, you got to read that carefully. The mass is 10 kilograms, the volume is 2 liters. It would be very easy to turn that around and put them in the wrong place. So then solving for K, we divide by 2, so K is equal to 5. Okay, so now we're going to take that value for K and plug it in right here. So we have M equals 5V. So now if they give us the volume, we can find the mass. They give us the mass, we can find the volume. So let's read the rest of the problem. What will be the volume, so we're looking for V, of 35 kilograms of the substance? So we just divide both sides by 5, and V is equal to 7. Okay, so that was a direct variation. It's always a straight line. All right, next one. It says the distance traversed by a car at a constant speed is directly proportional to the time spent traveling. So directly proportional to, varies directly, all of those mean the same thing. It's a straight line. And if you look at the bottom of page 474 and the top of page 475, it gives you examples of different ways to say varies directly or directly proportional. All right, now this one says if the car goes 75 kilometers, well, that's a distance, guys, in 5 hours, that's the time. So solve it for K. So K is going to be equal to 15. Take that and plug it back in for K. So D equals 15T. If the car, how far will it go? So we're looking for the distance in 7 hours. Plug in 7 for the time, and the distance will be 105. Okay, so 105 kilometers in 7 hours. All right, one more on this page. This says, under certain conditions, the pressure of a gas varies directly as the temperature. When the pressure is 800 pascals, the temperature is 400 Kelvin. Solve for K. By the way, guys, K doesn't always have to be a whole number. Sometimes it will come out to be a fraction. So don't be worried if it does come out to be a fraction. All of these have come out to be whole numbers. So P is equal to 2T. And then it says, what is the temperature? So we're looking for T when the pressure is 400 pascals. I'll just divide both sides by 2. The temperature will be 200 kelvins. All right, so that's direct. Next, we're going to do a couple of examples with inverse variation, or varying inversely or indirectly. Again, on page 476, they have some phrases there that will tell you that it's an inverse variation. So this one says, under certain conditions, the pressure of a perfect gas varies inversely. So this is going to be the fraction. Inversely as the volume. Okay. When the pressure of a quantity of gas is 7 pascals, the volume is 75 liters. So here, to solve for K, we cross multiply. So we get K is equal to 525. So take this and put it in for K. So now we'll have P is equal to 525 over V. And we'll read the rest of the problem. What would be the volume? So we're looking for volume if the pressure is increased to 15. Okay, again, we cross multiply. So when we do that, we have 15V equals 525. So to get V by itself, we divide both sides by 15. And we have V equals, let's see, what is that? Goes in there 35 times. And that was measured in liters, so this would be 35 liters. All right, so the only difference is to find the constant, you have to cross multiply to find it. And then you also have to cross multiply here to solve. All right, one more. This is 113.5 down at the bottom of page 476. To travel a fixed distance, the rate is inversely proportional to the time required. When the rate is 60 kilometers per hour, the time required is 4. Okay, so let's go ahead and solve for K. K equals 4 times 60, which is 240. Take that, plug it in for K. So R is equal to 240 over T. And then it says what would be the time required, so again we're solving for what's in the denominator, when the rate was increased to 80 kilometers per hour. Alright, so again we're going to cross multiply. So we'll get 240 equals 80T. And divide both sides by 80. So T will be equal to 3. And that was hours. Alright, so lots of good practice on this.